Dear students, in this class, let us see the concept of perpendicular and parallel polarizations. And polarization refers to the behavior of electric field intensity at a particular point in the space. And we discussed very clearly the different types of polarizations like linear, circular and elliptical polarizations. And in this class, let us focus on the definitions of perpendicular and parallel polarizations here. So before going for that, so let me say, whenever you are taking a boundary surface like this, is a boundary, that means it is an interface between the two mediums. So which is separating two mediums. Let it be the medium 1 and this is medium 2. And whenever the wave is coming at an angle of 90 degrees to this is called as normal incidence. But practically the people are always using oblique incidence for the communication purpose. Means other than normal, if the wave is coming at an angle, it is called oblique incidence. And if the wave is coming at an angle of 90 or otherwise in the normal direction, it is called normal incidence. But practically in all communications, the wave is always propagating between the two boundaries. So whenever you are taking two boundaries like this, if the wave is coming oblique in an oblique direction like this, whenever it is hitting this, it will be reflected back to up to this boundary. Again it will be reflected and again it will be reflected like this. So in future you can see this type of wave propagation in your waveguides also. అంచేత వేవ్ ఎప్పుడూ కూడా ఆబ్లిక్ డైరెక్షన్లో ఇలా వచ్చినప్పుడు then it will be reflected back here with some the same angle and again it will be reflected back whenever you are taking the two boundaries like this. And whenever the wave is coming in the oblique direction and touching the surface of this interface means which is separating two mediums, then you have to consider two cases. Number one, the electric field may be vertical or the electric field may be horizontal. So that means the direction of the electric field is going to tell about the polarizations like perpendicular and parallel polarizations. So if you want to understand this perpendicular and parallel polarizations, and you see this, chudandi, this is called incident ray. This is called as incident ray. And incident ray is actually hitting the surface of a boundary with some angle. Konta angle toti with respect to z-axis, it is actually hitting this one at an angle theta 1 here. So theta 1 is the angle made with this z-axis. And y-axis is nothing but your boundary. And this is called medium 1 and this is called medium 2. Whenever the wave is coming from medium 1 to medium 2 in the oblique direction like this, ఇది ఇలా వచ్చి ఈ బౌండరీని ఇక్కడ టచ్ చేసినప్పుడు this incident ray is coming like this, it may be reflected and it may be refracted also depending upon the medium properties, depending upon the boundary properties. If it is a perfect conductor, and perfect conductor always reflects electromagnetic energy, incident energy anta kuda reflect అయిపోతుంది. If it is not perfect, something will be refracted also, something will be transmitted to the medium 2 also. Now let me say very clearly, this is nothing but the plane of incidence. Be careful, please try to understand it very clearly. What do you mean by the plane of incidence? Plane of incidence means it consists of an incident ray as well as your normal. Normal means it is nothing but a z-axis. So incident ray plus normal is nothing but your plane of incidence. This is the definition of plane of incidence. So exactly like this, if you are taking this one, it is called plane of reflection. Plane of reflection means it consists of a reflected ray as well as normal. So normal reflected ray ఉన్నటువంటి దాన్ని plane of reflection అంటారు. And this is called plane of incidence అంటారు. This is called as plane of refraction or otherwise a transmission. This means it's the medium 2. This is called medium 1 and this is called medium 2. So whenever the wave is coming like this, okay, Transmission will be in the same direction, but the reflection will be in the opposite direction like this. ఇలా వెళ్తూ ఉంటుంది. Of course, in the same medium. Now, listen carefully. The wave means it is having two fields, electric field as well as magnetic field. This dot is indicating the electric field is perpendicular to this. That means, let us take, this is a electric field vector. It is perpendicular to this plane of incidence. Just now I told you, this is called plane of incidence. If the electric field is perpendicular to the plane of incidence, it is called as perpendicular polarization. Remember friends, what is meant by polarization? Polarization means always telling about electric field intensity. Here what I am telling is, this dot is indicating the electric field is vertical. This electric field is at an angle of 90 degrees. So the electric field is at an angle of 90 degrees to the plane of incidence. Then it is called as perpendicular polarization, because it is perpendicular to the plane of incidence. At the same time, if you take this boundary surface, this electric field is parallel to this boundary surface. So like this, suppose if you are taking, this is the boundary which is separating the two mediums, medium 1 and medium 2. Here if you see it, the electric field is perpendicular to the plane of incidence. ఈ plane of incidence ని reference గా తీసుకుంటే it is perpendicular, but at the same time I can say it is parallel to the boundary surface also. This is the boundary surface, దీనికి parallel గా ఉంది చూడండి. So there are two ways of telling. Electric field is perpendicular to the plane of incidence or otherwise parallel to the boundary surface. So if the electric field is perpendicular to the plane of incidence, it is called as perpendicular polarization. Or otherwise, if the electric field is parallel to the boundary surface, it is parallel. చూడండి ఇక్కడ తీసుకోరండి, parallel to the boundary surface, it is called as, horizontal polarization. There are two names given to the same condition, friends. Remember this. Plane of incidence తో చెప్పినప్పుడు perpendicular అన్నాను. Boundary surface with respect to boundary surface చెప్పినప్పుడు horizontal polarization అన్నాం. So, boundary surface is always having the nomenclature of horizontal and vertical. But whereas the plane of incidence is having perpendicular or otherwise parallel, it may be. So that's why the same situation I can say, once again I repeat, if the electric field intensity is perpendicular to the plane of incidence, it is called as perpendicular polarization. Or if this electric field is parallel to the boundary surface, it is called as horizontal polarization. So what does it mean? Perpendicular polarization and horizontal polarization is same. But this perpendicular is the name given with respect to plane of incidence, and this horizontal polarization is the name given with respect to the boundary surface. అంచేత రెండు పేర్లు ఉంటాయి. ఇట్ జస్ట్ లైక్ ఏం గుర్తొస్తుందంటే, నాకు మనం ఉంటాం, అమ్మమ్మ గారు ఒక పేరు పెడితే నాన్నమ్మ గారు ఒక పేరు పెడుతుంటారు. ఆ ఇంట్లో ఒక పేరుతో పిలిస్తే చాలామంది ఇంట్లో ఇంకొక పేరుతో పిలుస్తుంటారు, కానీ మనిషి ఒక్కడే. ఎగ్జాక్ట్లీ లైక్ దిస్, ప్రాంతాన్ని బట్టి పేర్లు అన్నట్టు జస్ట్ ఈ ప్లేన్ ఆఫ్ ఇన్సిడెన్స్ని కనుక మీరు దృష్టిలో పెట్టుకుంటే పర్పెండిక్యులర్ పోలరైజేషన్, అండ్ ఇఫ్ ద బౌండరీ సర్ఫేస్ ఈస్ ద రెఫరెన్స్, then it is called horizontal polarization. So what is the definition here? If the electric field is perpendicular to the plane of incidence or parallel to the boundary surface, it is called as perpendicular or horizontal polarization. Perpendicular or horizontal polarization. That's why I can say this perpendicular polarization is also called as horizontal, because the electric field intensity is parallel to the boundary surface. Now you see once again here, the incident wave is coming and hitting the interface here, and it is reflected back in this direction, and it is transmitted into the second medium in this direction like this. And the direction is also much more important here. So this dot is indicating it is out of the board, బయటకు వస్తుంది అని. But here you have to observe very closely here. This is the HI, incident magnetic field, incident electric field here. So this is the called electric field direction here. and H field is here. Always remember the direction is always given as E cross H will give you the direction. That means I can say AK, that means direction of the wave is equal to cross product of electric field vector into magnetic field vector. This is. So E cross H will give you the direction of the wave here. So E is in this direction. Electric field is always perpendicular to this. E cross H means it is rotating like this. So if E is crossing H, the wave is coming in this direction. And this wave is making an angle theta with this normal. So I can demonstrate this with a practical example like this. This is. Now let me say this is the wave. This is the wave here like this. So this is electric field vector. This is electric field vector. Electric field is at an angle of 90 degrees to this plane of incidence, means it is perpendicular to the plane of incidence, and this is called HI. You can remember this. Now E is crossing H. E is crossing H. E is crossing H means if you are rotating like this, if you observe closely, it is actually in this direction. So the wave is coming in this direction. So you can say that this is electric field and this is crossing H like this. So whenever it is crossing H like this, the wave is going in this direction. This is called as incident wave. Exactly, if you are taking here like this, now here this is the field, now this is electric field once again and the magnetic field like this. And now the reflected wave should be in this direction only like this. So that's why if you are rotating like this, E cross H, this is E and this is H. E is crossing H means in this direction if you rotate like this, you see the nut is going in this direction. That means the wave is going in this direction like this. So always remember, my dear friends, E cross H will give you the direction of the wave, the direction of the wave. So you can understand it very clearly. Whenever the wave is coming here, this is the electric field vector and this is HI. HI will give you the direction of this. So the direction of this electromagnetic wave will be given by EI cross HI. This is nothing but the direction. And for this reflected wave also, you have to say ER cross HR. This is nothing but the direction of this. And for the transmitted wave also, it has to come in this direction. So that's why ET is once again in this direction. ET, it is in this direction like this, ET at an angle like this. So E is crossing H means it is rotating like this in this direction. So that's why the wave is going in this direction. So this is called ET cross HT. This is nothing but the transmitted wave like this. And remember, whenever the wave is coming and hitting the boundary surface here, I told you you have to consider two cases. Number one is electric field is perpendicular to the plane of incidence. This perpendicular to the plane of incidence means it is parallel to the boundary surface, or otherwise it is called as horizontal polarization. Horizontal polarization. That's why perpendicular polarization is also called as horizontal polarization. So now coming for the next one, which is nothing but the parallel polarization. Here what you have to remember is, if the magnetic field is perpendicular to the plane of incidence, Anna, otherwise if the electric field is parallel to the plane of incidence, Anna, vakate. If the electric field is parallel to the plane of incidence, or if you take this boundary and it is normal to this boundary surface, that means perpendicular to the boundary surface. జాగ్రత్తగా గమనించండి, ఎలక్ట్రిక్ ఫీల్డ్ ప్యారలల్ టు ది ప్లేన్ ఆఫ్ ఇన్సిడెన్స్ అన్నా, ఆర్ అదర్వైజ్ యూ కెన్ సే ఇట్ ఈస్ పర్పెండిక్యులర్ టు ద బౌండరీ సర్ఫేస్ అన్నా ఒకటే. సో ఇఫ్ ఇట్ ఈస్ ప్యారలల్ టు ద ప్లేన్ ఆఫ్ ఇన్సిడెన్స్, ఇట్ ఈస్ కాల్డ్ యాజ్ ప్యారలల్ పోలరైజేషన్ అంటారు. అండ్ ఇఫ్ ఇట్ ఈస్ వెర్టికల్ టు ద బౌండరీ సర్ఫేస్, ఈ బౌండరీ సర్ఫేస్ వెర్టికల్గా ఉంది కాబట్టి, సో దిస్ ఇస్ ద బౌండరీ సర్ఫేస్ వెర్టికల్గా ఉంది కాబట్టి దీన్ని వెర్టికల్ పోలరైజేషన్ అని అనొచ్చు. So it is also telling about if the electric field intensity is parallel to the plane of incidence or perpendicular to the boundary surface, then it can be called as parallel polarization or vertical polarization. Plane of incidence తోటి మాట్లాడితే parallel polarization, బౌండరీ సర్ఫేస్ని ఉద్దేశించి మాట్లాడితే ఇట్ ఈస్ vertical polarization. That's why parallel polarization is also called as vertical polarization. So vertical polarization. And here also, whenever the wave is coming and hitting this one, and it may be reflected or it may be refracted, whatever it may be. But what you have to remember is the direction of the wave is important here. So here the incident wave direction is A cross HI, and reflected wave means ER cross HR, and transmitted means ET cross HT, because you know the power pointing theorem always give you the cross product of electric field intensity and magnetic field intensity, E cross H. So this will give you the direction of the wave as well as the power carried by the electromagnetic wave. So I hope you understood this, because the direction of this electric field decides the polarizations. So from now onwards, try to understand the plane of incidence first. What is plane of incidence? Plane of incidence means which consists of incident ray and normal. అంటే ఇది ఈ ప్లేన్ ఆఫ్ ఇన్సిడెన్స్లో ఉన్న ఎలక్ట్రిక్ ఫీల్డ్ పర్పెండిక్యులర్గా ఉంటే కనుక ప్లేన్ ఆఫ్ ఇన్సిడెన్స్కి పర్పెండిక్యులర్ పోలరైజేషన్, అదే కనుక ప్యారలల్గా ఉంటే కనుక ప్యారలల్ పోలరైజేషన్. అదే విత్ రెస్పెక్ట్ టు ద బౌండరీ సర్ఫేస్ కనుక అయితే కనుక విత్ రెస్పెక్ట్ టు ద బౌండరీ సర్ఫేస్ కనుక ఇట్ ఈస్ ప్యారలల్గా ఉందనుకోండి, దెన్ ఇట్ ఈస్ కాల్డ్ యాజ్ యూ కెన్ సే హారిజంటల్ పోలరైజేషన్. And with respect to this boundary surface, if it is perpendicular like this, it is called vertical polarization. So from now onwards, there are two types of polarizations you have to remember whenever the wave is propagating from one point to the other point. It may be perpendicular or it may be parallel. But coming to this, practical communications, always remember you have to use your vertical polarization only. That means direction of propagations ఇలా వచ్చినప్పుడు electric field is always vertical like this, ఇలా ఉంటుంది. And whenever it is hitting the surface of the earth, suppose earth is a perfect conductor, ఎర్త్ని కనుక టచ్ చేస్తుంది అనుకోండి, again it will bump with vertical polarization like this only. If you are using horizontal polarization, suppose if you are taking a wave like this, if you are using horizontal polarization, and whenever it is touching the surface of this earth, it will die here. So in the practical communications, always we are using vertical polarization. That vertical polarization is nothing but your parallel polarizations here. And remember, this is perpendicular polarization or horizontal polarizations is practically of very less use. And coming to this, most important one more concept is there, which will be discussed in the next class, that is nothing but the Bravastar angle. So what is the meaning of Bravastar angle, friends? Bravastar angle ante emiti? It is an angle of incidence at which there is no reflection. Suppose I am a teacher, I am teaching a concept to you, students are listening my concept here. నేను ఏ యాంగిల్ ఆఫ్ ఇన్సిడెన్స్తో పాఠం చెబితే వెనక్కి రాకుండా పిల్లలందరికీ అర్థం అవుతుందో దాన్ని బ్రవస్టర్ యాంగిల్ అంటారు. So Bravastar angle is nothing but an angle of incidence at which there is no reflection at all. But Bravastar angle is defined in which polarization? Vertical polarization, not in horizontal polarization. Do you know what is the reason? What is the polarization? Polarization means which refers to the behavior of electric field intensity at a particular point in the space. But I am telling you, Bravastar angle is defined only for this vertical polarization, not the horizontal polarization. ఇప్పుడు మనం ఉన్నాం, మనందరమే, everybody is having two polarizations daily. During the daytime I am so active, that's why I am awake. నేను మెలకువగా ఉంటాను, I have to use only vertical polarization. Whenever I am strained, then I have to take the rest. During the night time I will be the horizontal polarization. అంటే రెండు పనులు, either horizontal polarization or vertical polarization. మెలకుగానే ఉండాలి, చక్కగా నిద్రపోతున్నాను ఉండాలి. అండ్ వెనెవర్ ఐఎమ్ ఆస్కింగ్ సంథింగ్ టు యూ ఆల్సో, అండ్ యూ హ్యావ్ టు నో అబౌట్ దీస్ పాలరైజేషన్స్. ఇఫ్ ఐఎమ్ ఆస్కింగ్ ఏ క్వశ్చన్ టు యూ, అమ్మ అర్థమైందా అంటే ఎస్, మీరేం చెప్పాలి? యూ హ్యావ్ టు సే ఓన్లీ టూ పాలరైజేషన్స్. హారిజంటల్ పాలరైజేషన్ అర్థం కాలేదు. ఎస్ సార్, వెర్టికల్ పాలరైజేషన్ అర్థమైంది. అంతేగాని యూ షుడ్ నాట్ యూజ్ థీటా పాలరైజేషన్. థీటా పాలరైజేషన్ ఈజ్ ఆల్వేస్ డేంజరస్. And see, whenever you are traveling in your buses, where you should be vertical, కూర్చొని చెప్పి చక్క కూర్చోవాలి, జస్ట్ లైక్ యోగా, ఆర్ అదర్వైజ్ యూ షుడ్ బి ఇన్ హారిజంటల్ పోలరైజేషన్, బ్రహ్మాండంగా పడుకోవాలి. బట్ ద పీపుల్ ఆర్ ఆల్వేస్ యూజింగ్ జస్ట్ లైక్ థీటా యాంగిల్లో ఉన్న చైర్స్తో కూర్చోవటం వల్ల యూ ఆర్ గెటింగ్ ఆర్థోపెడిక్ ప్రాబ్లమ్స్. సో దేర్ ఆర్ టూ పర్ఫెక్ట్ పోలరైజేషన్స్ హియర్, హారిజంటల్ అండ్ వెర్టికల్. బట్ వాట్ ఐఎమ్ ఆస్కింగ్ ఈస్, why this Bravastar angle is not defined in horizontal polarization? Horizontal polarization means, what does it mean? Horizontal polarization means taking the rest. అంటే the person who is sleeping, పడుకున్నటువంటి వ్యక్తికి పాఠం చెప్పేది ఏముంటుంది, ఉండదు. అంటే the angle of incidence at which there is no reflection is not valid for this. వెర్టికల్ పోలరైజేషన్ మెలకుగా ఉన్నవాడికి ఏ యాంగిల్లో నేను పాఠం అయితే చెబితే వాడికి పూర్తిగా అర్థమవుతుందో, దట్ ఈస్ కాల్డ్ యాజ్ బ్రవస్టర్ యాంగిల్. చాలామంది కాన్సెప్ట్ అర్థం చేసుకుని చాలా ఈజీగా రాసేసేయచ్చు, ఏదో బట్టి మామూలుగా ఈక్వేషన్స్ రాస్తే రాదు. సో దట్స్ ద రీజన్ వాట్ ఐ మీన్ టు సే ఇస్, మై డియర్ ఫ్రెండ్స్, బ్రవస్టర్ యాంగిల్ ఈజ్ అన్ యాంగిల్ ఆఫ్ ఇన్సిడెన్స్ ఎట్ విచ్ దేర్ ఈజ్ నో రిఫ్లెక్షన్ అట్ ఆల్. మనం ఏ యాంగిల్ ఆఫ్ ఇన్సిడెన్స్తో అయితే కనుక లెసన్ చెప్తే పక్క వాళ్ళకి అర్థమవుతుందో, మీరు ఏ రకంగా అయితే పక్క వాళ్ళకి అర్థమైనట్టు చెబుతున్నారో ఆ యాంగిల్ని ఏమంటామంటే బ్రవస్టర్ యాంగిల్ అంటారు. That Bravastar angle derivation is also there, which will be discussed in the next class. Okay, so this is the way of understanding perpendicular and parallel polarizations. Once again, I will tell you, always your definition depends on the direction of the electric field vector. Plane of incidence ki perpendicular ga unte perpendicular polarization, plane of incidence ki electric field parallel ga unte parallel polarization. ఇదే ఎలక్ట్రిక్ ఫీల్డ్ వెక్టార్ బౌండరీ సర్ఫేస్ చూస్తే కనుక ఇట్ ఈజ్ ప్యారలల్గా ఉంటుంది కాబట్టి దిస్ ఈజ్ హారిజంటల్ పోలరైజేషన్. అంటే భూమికి సమాంతరంగా ఉన్నాం మనం, అంటే మంచం ఉంది, ఇఫ్ యూ టేక్ యువర్ కాట్ మీద పడుకున్నామంటే ప్యారలల్ పోలరైజేషన్, దట్ ఈజ్ నథింగ్, సారీ, ఇట్ ఈజ్ హారిజంటల్ పోలరైజేషన్, పడుకుంటాం మనం. ఎగ్జాక్ట్లీ హియర్ ఆల్సో యూ కెన్ సే దట్ దిస్ ఈజ్, ఇఫ్ ద ఎలక్ట్రిక్ ఫీల్డ్ ఇంటెన్సిటీ ఈజ్ ప్యారలల్ టు ద బౌండరీ సర్ఫేస్ అంటే at an angle of 90 degrees to the boundary surface అని అర్థం, అంటే వెర్టికల్గా ఉన్నాడు అని అర్థం. దట్స్ వెర్టికల్ పోలరైజేషన్ అంటారు. సో నౌ లెట్ us summarize the definitions of perpendicular and parallel polarizations. So what I told you, if the electric field is perpendicular to the plane of incidence or parallel to the boundary surface, it is called perpendicular or horizontal polarization. If the electric field is parallel to the plane of incidence, or otherwise you can say in another direction also, the magnetic field is parallel to the boundary surface also, then it is called as your parallel polarizations. So that's why you see the definition here. First of all, see the definition of the plane of incidence. Plane of incidence, plane containing incident ray and normal to the surface. So this is called incident ray and normal to the surface. This is plane of incidence. What is perpendicular polarization? This is also one way of writing this, perpendicular polarization. ఇలా కూడా రాయొచ్చు. The electric field vector is perpendicular to the plane of incidence or parallel to the boundary surface. It is also known as horizontal polarization. బౌండరీ సర్ఫేస్తో పేరు పెడితేనేమో హారిజంటల్, ప్లేన్ ఆఫ్ ఇన్సిడెన్స్తో పేరు పెడితే వచ్చేసి పర్పెండిక్యులర్ పోలరైజేషన్. సో లైక్ దిస్ యూ సీ దిస్ parallel polarization here. The electric field is parallel to the plane of incidence or magnetic field is parallel to the boundary surface. Magnetic field తో కూడా చెప్పొచ్చు, వెరీ సింపుల్. ఎలక్ట్రిక్ ఫీల్డ్ ఈజ్ ప్యారలల్ టు ది ప్లేన్ ఆఫ్ ఇన్సిడెన్స్ అని ఎలా చెప్తామో, అప్పుడు ఆ టైంలో మ్యాగ్నెటిక్ ఫీల్డ్ ఈజ్ ప్యారలల్ టు ద బౌండరీ సర్ఫేస్, ఆపోజిట్. ఆర్ అదర్వైజ్ ఇఫ్ ద ఎలక్ట్రిక్ ఫీల్డ్ ఈజ్ వెర్టికల్ టు దిస్ బౌండరీ సర్ఫేస్, ఇట్ ఈస్ కాల్డ్ యాజ్ వెర్టికల్ పోలరైజేషన్. సో వాట్ ఆర్ ఇట్ మే బి, always try to speak the definitions with respect to the direction of electric field vector with the plane of incidence or boundary surface. Finally, I conclude, with respect to the plane of incidence, there are two terms you have to use, perpendicular and parallel. With respect to the boundary surface, you have to use horizontal and vertical polarizations. Okay, I hope you understood the definitions of this very clearly. So let us use these definitions for the next cases like reflection by electromagnetic waves at oblique incidence by both conductors and insulators. Okay, thank you.